Hey, and we're back. Hey, everybody. Um, welcome to the ISA Community Global Webinar Series. I'm Paul Price. I'm one of your hosts. Our hosts are growing. I have a co-host with me today, guy I've worked with for, 10, 15 years. And our speaker today is someone I've known for 15 years, and I would love to, or 10, maybe 10, right, Mark, when we first met, I guess. But it's been a long time. And we're gonna do a talk today on anti-patterns and patterns. But first, I'm gonna give you a little what's new story at ISA. I like to keep people up to date, and quite frankly, a lot of my job now is turning into what's new at what other people are doing, which I think is kind of the coolest job in the world. Is I get to talk about what's going on with a bunch of contributors and thought leaders, and folks that are really working hard to make an architecture profession, not just an architecture, not just an individual architecture practice, but really bringing us all together. And there's so much going on in our content world now. Webinars, this one is one of them. Videos and articles is another one, and learning. And I've got a couple of really cool things to announce there. So there's just, boy, I just don't know how to talk about all of it at once. Today, of course, we've got the world-renowned Mark Richards to talk about patterns and and pitfalls, anti-patterns and pitfalls. But next 2 weeks from now, we have a friend of mine, Michael Carducci, who's going to talk about AI data is being useless without a semantic layer. I am a big believer in the ontology knowledge graph movement, building ones ourselves for ISA and the Bitabox. So cool stuff there for you to use later. And then September 23rd, another major contributor, Rohith, is going to be talking about decisions and making better decisions and how to deal with the people angle of decisions. And he's built some beautiful articles in the Bitabox as well as in the journal for that. So upcoming, we have courses. So we have our core course, which is, boy, been taught to about almost 10,000 people now. Core Spanish in person, core Ireland in person, core online, and the Netherlands coming up very soon. All of those taught by local teachers in local languages. So it's fully international. But I really want to point out Arc for Dev. So we have an Arc for Dev class by Annalie Garlington. We have Agile Architecture at Scale with a big AI addition to it. So that'll be kind of an Agile AI Architecture at Scale course, and that's taught by myself. It's short, sweet, and powerful. Fundamentals of Continuous Architecture. That's Owen Woods. And if you've not read Owen's software systems architecture book, we used to call it the Big Orange Book. It's white now, but we used to talk about it all the time and still do, quite frankly. And there's some really cool stuff happening in views and viewpoints in the Bitabox that Owen is a part of. And then finally, AI architecture coming in November. That is just taught in Ireland and went unbelievably well. It's a pretty highly demanded course now for us. So lots going on. Would love, this is a professional association. This is not just a thought leader association. How about you become the next thought leader? How about you are the thought leader, right? We have journal articles, peer reviewed, course author opportunities, and speaking opportunities on webinars like this one, and in our communities. And we have about 18 communities running with their own chapter presidents and their own community leadership. It's a very powerful moment in our history. So if you want to sign up for this, remember education.isaglobal.org. Become a contributor. It will take you right there. We got a bunch of latest content, which is very blurry, apparently. On education.isaglobal.org, you will find our latest articles and our latest things. Those just did not resolve at all, did they? The content includes 400 plus videos, 1,000 plus published items, about 44,000 members. That's about to turn to 45,000. It's growing so fast. So we couldn't even keep up with the slides. Free courses at different membership levels, and some that are just free. So ISA membership is kind of the way to go. Now, it is my pleasure, privilege, honor, what do you want to call that, to introduce Mark Richards, who I guess the last time we did one of these, Mark, was in COVID. Was that the last time we did an actual?
I think so. It's been a couple of years at least. Yes.
A couple of years, right? Well, welcome, and thank you so much for doing this. I'm really excited about the talk. Anything, I've got a bunch of load of questions for you, but I'm just going to turn it on and let you go straight into it. So I'm going to turn your slide deck on and turn my face off, let you go in. And look at those books, by the way. I have read all of these and I don't have a single signed copy.
Oh, wow. We'll have to fix that somehow.
We got to fix that somehow. All right, I'm going to shut up now and let our members hear from you.
Okay, wonderful. Thank you so much, Paul. And welcome, everyone. I usually, when I do online kind of webinars or such or classes, I usually am known to say, good morning, good afternoon, and good evening, probably to some of you actually listening. So anyways, thanks. Back on the stream. And, we talk a lot about patterns, and there's so much material and so many classes and webinars about patterns, either design patterns or architecture patterns. Yet those are things, they're basically repeatable processes that produce positive results. And we embrace those patterns, but we rarely talk about anti-patterns and pitfalls, things that maybe we shouldn't do. And that's what I'm going to focus on in this particular webinar. And as a matter of fact, one of the things we're actually going to be looking at, and let me just get focus here, there it is a book that is currently in production. So this should be released in the next probably 4 to 6 weeks, hopefully next month. Which I'm drawing material off of, is our book, which I co-wrote with Neil Ford and Raju Gandhi on software architecture patterns, anti-patterns, and pitfalls. In this webinar, I'm going to show you a couple of anti-patterns and a couple of pitfalls. So, before we get started, you might be wondering, well, is there a difference between an anti-pattern and a pitfall? And as a matter of fact, there is. And I'm going to demonstrate that for you in this webinar, because an anti-pattern is something that seems like a good idea at the time, but can lead you down a bad path. And as a matter of fact, anti-patterns actually have some trade-offs, and there's some that are positive, most are negative. But a pitfall is something that's never a good idea, even from the start, and doesn't have any significant positive trade-offs. And so we're going to take a look at both of these in this webinar, but let's start with anti-patterns. Seems like a good idea. Maybe we should go this route, but it can lead you down a bad path. So a while ago, a long time ago, as a matter of fact, Martin Fowler wrote an article, and it was "Who Needs an Architect?" And this was a seminal article that really talked about the role of a software architect. Well, I want to turn that around and say, well, who needs an architecture? So forget about architects, but who needs an architecture? And it's interesting when we ask that question, because let's put it this way. If you're building a doghouse, you don't need an architecture. All you need is some lumber, some nails, a hammer, and obviously a really cute dog. But if we're building or constructing a 10-story office building, we have to have an architecture. And as a matter of fact, if we don't, those buildings kind of start to look like this. And this is, by the way, this was not generated by AI. This is an actual photo of a building in Toronto, Canada. This is the Royal Ontario Museum. And what an interesting, but quote, ugly architecture. All right, so who needs an architecture? Let's talk about the first anti-pattern, which is called architecture by implication anti-pattern. Now, architecture by implication is implementing a system or a product without considering an architecture. In other words, the architecture is just really implied. Now, I want to show you three different factors that will help answer the question, am I building a simple dog house for my cute dog? Or am I building a 10-story office building? So let me show you those three factors. So the first factor is what we call a degree of ephemerality. Now, something that's ephemeral is something that's temporary. And so when we look at high degrees of ephemerality, this is a state of lasting for only a very short period of time. A quick tool or a quick product just to get something out for the next couple of days or weeks, versus a low degree of ephemerality means something's permanent. That's probably going to last forever. And when we look at and analyze in our systems or products this degree of ephemerality, systems or products with a high degree of ephemerality means that they're pretty much temporary and typically don't need an architecture. But low degrees of ephemerality, systems over here usually don't survive or work well without an architecture. Okay, so that's our first factor. Our second factor is the degree of complexity. And so when we think about systems that are simple, have a low degree of complexity, this is the quality of being easy to understand, create, and maintain. However, once we move in this spectrum over to a high degree of complexity, this is the state of systems having many moving parts that connect in various intricate ways, making it really hard to understand or create or even maintain that system. Okay, so when we talk about complexity, systems over here typically don't need an architecture, but systems with a high degree of complexity typically can't survive without an architecture. So now we have two factors. Well, there's a third factor we're going to look at in this whole architecture by implication, and that's the degree of capabilities. So over here, we may have some insignificant capabilities, or maybe even none at all. So there's no critical or important architectural characteristics required. Things like scalability, elasticity, maintainability. It's similar to the simple system, but it may be a complex system that just, we don't need any of these capabilities. But when we move to a high degree of capabilities, in other words, significant, we have a lot of critical or important architectural characteristics. So in this third factor, systems over here with insignificant or no capabilities typically don't need an architecture, but systems over here won't survive without an architecture. So let's take a look and let's play around with these three, because not any one of these will determine whether you need an architecture or not. So let's play a little game. I'm going to show you four different scenarios that change the degrees of ephemerality, complexity, and capabilities, and see where in the spectrum we are in terms of saying, do I need to be concerned about architecture for this system? So let's take our first one. Let's say we have a kids' soccer, well, we call it soccer here in the States, but football registration website for the upcoming season. When we talk about ephemerality, this is a fairly ephemeral, high degree of ephemerality. And in other words, it's pretty temporary. It's just for the upcoming season. It's just a simple registration website. So it's fairly simple, and we don't need a lot of capabilities. We don't need things like scalability or maintainability or elasticity or responsiveness. It's just a website to register your kids. And so we can see here, this is one extreme where we say, I don't need to be much concerned about architecture. In other words, this is like the doghouse we're building. All right, so let's see another example. This one's really interesting. So this is a small company that wants to put up some brochureware, an advertising kind of website to advertise what we do and our products and our contact us page. Okay. Here, notice we're probably going to stay around a while. So the degree of ephemerality is fairly low, meaning, yeah, this is going to stay around for several years, I'm guessing. Do we need to be concerned about an architecture then? Maybe not. And that's why all three of these factors need to be taken into account, because this is a pretty simple website. As a matter of fact, I'm guessing we wouldn't write it. Yes, we are going to be talking about agentic code generation in this webinar. And as a matter of fact, we talk about it right here. Yeah, this is pretty simple. And because it's just brochureware in a small company, we really don't have that many significant capabilities, those architectural characteristics that define an architecture. And so consequently, you can see, no, we don't need to be concerned about architecture. Now, let's just take a step back and think about this particular scenario, because we have a low degree of ephemerality, which might say, oh, well, if this is more permanent, you should probably have an architecture. But the other two factors drive that down to say, yeah, it's not temporary, but it's simple and there's no capabilities. We don't need to be concerned about an architecture. Let me show you another really interesting scenario. So let's say we just need to stand up a one-time ticketing system for the upcoming Taylor Swift concert. Well, we know that that's going to be selling out, and we know we're going to have millions of users, but it's temporary. It's got a high degree of ephemerality. And so consequently, we might say, oh, yeah, let's just get this thing written. Let's just stand it up because we're going to throw it away afterwards. So architects or managers might say, don't worry about the architecture. Just get the thing to work. However, ticketing systems have a fairly high degree of complexity, especially when you think about the fact that there's 1,500 concurrent users all after the same seat. And what about our capabilities? Very significant. We're talking about scalability, elasticity, responsiveness, concurrency, all those kind of architectural characteristics that basically systems can't survive without those. And so here is an interesting example where ephemerality is high, which may drive you to say, oh, yeah, this is just temporary. But you know what? If we don't pay attention to complexity and capabilities, that system would come crashing down in the first minute that we opened up tickets. So now we can start to see where all three of these kind of have a play. Now, one more example to show you the other extreme. This is a well-established, high-volume, worldwide online retailer, and this is an ordering and a distribution system. Well, if it's well-established, high-volume, worldwide online retailer, this is pretty permanent. As a matter of fact, that's a fairly complex type of system to actually maintain and highly significant capabilities. So yeah, this system will not survive without an architecture. All right, so those are the three factors that we can actually use as a tool to answer our own question. Do I need to spend the time and cost and effort to worry about architecture and create an architecture for a system that's ephemeral, simple, and insignificant? And so we can use this as a range to know how much architecture and how much I should be concerned about that architecture. Well, it turns out we are in an anti-pattern called architecture by implication. And again, that means basically creating a system without thinking about the architecture. And guess why this is such a prevalent anti-pattern? Yeah, you guessed it. It's because of agentic AI. And it looks like I might have, screen might be, oh, there it is. Okay, just froze a little bit there. All right, that transition was supposed to be smoother than that. You know, we do a lot of agentic code generation. And one of the criticisms that is currently existing in the industry is that agents are great at behavior, but they don't know much about architecture. And so consequently, those agents don't take architecture into account. And while all tests pass, the system won't scale. It's not maintainable. It's not responsive. It's not elastic. It's not available. It's not fault tolerant. All of these kind of architectural characteristics. Now, I showed you a book that is currently in production at O'Reilly on our software architecture patterns, anti-patterns, and pitfalls. It turns out we are concurrently writing another book, which is we're just putting the finishing touches on it. That basically, oh, there it is architecture as code. In other words, this is how we can use a language which we call ADL. It's a pseudo language we developed, we being Neil Ford and myself, to be able to describe an architecture for not only humans, but also agents. So this is one of the contributing factors that lead to this anti-pattern. But we can't blame AI alone. Yeah, it's also companies, humans, and management. And let me show you an example of where this anti-pattern can occur. So we all know this kind of like this CAP theorem of developing systems. And I say it's CAP theorem like. There's three things we can do: good, cheap, and fast. But like CAP theorem, you can only pick two. In other words, I can make this system good and cheap, but it's going to take a while. In other words, fast is not in terms of responsiveness, but how long it's going to take to develop that system. Well, I can develop this system quickly and make it good, but it's going to cost you. And that's the second one. However, the third one, I can make it cheap and I can get it done quickly, but it's not going to be good. Well, guess what? Our pointy-haired boss that we just saw, you guessed it, is likely going to pick this option. I want it cheap and I want it fast, and it won't be good. And what's missing from that cheap and fast? Typically concerns about architecture. And so these are the contributing factors to this anti-pattern. Now, I want to answer this question here, but Mark, why isn't this a pitfall? I mean, I would think that, don't forget, an anti-pattern is something that seems like a good idea at the time, but can lead you down a bad path. Whereas a pitfall is something that's never a good idea. Let me show you why this is an anti-pattern. Here's that youth or that kid's soccer registration site for the upcoming season. And as a matter of fact, this is a website in Hungary, and this is in Dog, Hungary. And it's just used by one of the soccer associations there. Okay, does this need an architecture? Well, let's analyze it. Instead of just saying yes, why don't we need to be concerned about architecture? This is for the upcoming season. It has a high degree of ephemerality. It's a fairly simple website, and it has fairly insignificant capabilities. There's maybe 20 kids that will be in this registration site. Okay. But what happens? So, is this a good idea? Sure. Yeah, look at the trade-offs that we're thinking about with this anti-pattern. Because if we focused on an architecture, it's going to take a lot longer. So it's a lot more effort and a lot more cost. And we don't need to incur that cost. But what happens? We start to expand. Other cities within Hungary want to start using this same website. So what happens to our degree of ephemerality? It starts going lower. And as a matter of fact, now that more people are using this, we start to need to be concerned about maybe some issues with scalability, albeit it's only 5 or 6 towns, but our capabilities start to become a little bit more significant. And what we do, because other people are using this, we add location type of services to scope it for whatever town in Hungary we're using this for. Or we may start forming leagues. And also we put an area where coaches can actually sign in to register. or even offer up their services for the particular leagues. Interesting. And this is the same system. This same system now, all of a sudden, is getting a little bit more complex due to those additional capabilities or behaviors, I should say. Now, all of Hungary is using this particular website for all soccer registration. Our ephemerality and capabilities start to increase a little bit more towards permanent, and now a little bit more scalability. We have to worry about concurrency, maybe location services get a little bit more intense. And because the entire country is now using this simple doghouse, we start adding things like tournaments. We start selling custom clothing, the outfits that kids wear for those soccer teams, and even start selling equipment. We have taken a simple website and now it has grown into an e-commerce site, which starts to increase the complexity. Of course, now other countries start saying, hey, this looks like a great system. Look at the behavior that you have here. And so other countries in Europe start to use this system. And notice the ephemerality now goes a lot lower, more towards permanent. We need to scale a lot more. And now all of a sudden, all of Europe starts to use this simple website. And of course, now our ephemerality is lowest possible with fairly significant capabilities. And you can guess what happens, everyone. Yep, it comes crashing down. Why? Because it didn't have an architecture. This is why it's an anti-pattern. Because it seems like a good idea at the time, but sometimes systems grow. And there's a message in what I just described there. Because a lot of systems that we create, a lot of products we create, don't need an architecture. But it's the responsibility of an architect to pay attention to these three factors to make the decision to say, you know what? This is no longer a simple website. We should add an architecture. Can you do that? The answer, folks, is no. And let me show you why. I want to talk about behavior versus capabilities. So when we talk about things like emergent design, what we have is this. There we go. Okay. So when we talk about emergent design, let's say we're building a lorry, a truck. Well, we're taught through emergent design that we don't design a lorry. We've never done that before. No, what we do with design is we start out simple, like with a roller skate, and then we turn it into a unicycle. We learn about the dynamics of an actual wheel, and then we add another wheel, make it a bicycle. We're learning about the problem. And from there, we add an engine, make it a motorcycle. From there, we make it a car. And finally, now that we see the dynamics and the load and the balance, now we can design that lorry. And this is called emergent design. It's something we're taught and something that's actually a good thing to do. But what we're describing here, folks, is behavior. However, with architecture, you can't do this. Because architecture is the capabilities of the system. Things like architectural characteristics, those ilities. And as a matter of fact, the capabilities of a roller skate don't even come close to the capabilities of a lorry or a truck. And when I say capabilities, I'm talking about all those architectural characteristics, those ilities that make up a system. Here's the point. There's a difference between the behavior of a system, what it does, places an order, versus its capabilities, like being able to scale. And here is the point with the soccer registration website. You cannot add architecture. You can't just say, oh, well, let's add an architecture. No, it requires planning. If we start out with that doghouse and want to make it a 10-story office building, folks, the behavior is the same. It encloses some rooms, but the capabilities are different. We can't just add architecture. Or things like this happens where we just decide to add some stairs that lead nowhere, or even in a house. That's the kids' room, by the way. Yeah. We can't just add architecture. As a matter of fact, let me demonstrate this even further through something called Gall's Law. Now, John Gall, back a long time ago, wrote this book called Systemantics. And in there, he coined Gall's Law. And this is what Gall's Law says, everyone. A complex system that works is invariably found to have evolved from a simple system that worked. The inverse proposition also appears to be true. A complex system designed from scratch never works and cannot be made to work. You have to start over, beginning with a working simple system. We can't just add architecture to that soccer registration website. The responsibility of an architect is to be able to analyze those three factors to decide when we need an architecture. And we can't just add it. We need now to start over. And as a matter of fact, let me show you an example of this. So let's apply Gall's Law to architecture. So start out with a simple system that will meet our scalability needs. And then we emerge the complex design. This simple system right here will scale to let's say 10,000 concurrent users. And we start emerging that design, continually checking our capabilities to make sure that we didn't impact them as we emerge the design. And so this is applying Gall's Law to architecture. And it's a pretty important message that we can't just add architecture to a system. We do have to start over. So how do we avoid this anti-pattern? Basically, it's considering all three of these factors: the degree of ephemerality, complexity, and capabilities, continuously analyzing those as we evolve the system. Okay, well, that's our first anti-pattern, but it's interesting because there's another associated anti-pattern with architecture by implication, and that's called the stovepipe architecture anti-pattern. Now, the stovepipe architecture anti-pattern is an ad hoc collection of semi-related ideas, concepts, structures, and components, resulting in basically an unreliable, brittle architecture that's hard to change. Yet another architecture anti-pattern. By the way, it gets its name from the fact of, in the old days, we had stovepipes to warm houses. And, well, the point is the stovepipe or the furnace or the stove was basically in one part of the house, but we need to vent it in another part. And so it's just a lot of these different stovepipes. So why is this an anti-pattern? Again, don't forget, anti-patterns are things that seem like a good idea, but can lead you down a bad path for the same reasons as the prior one that we saw. Cost, time, effort are all going to be impacted. And let me show you an example of both a monolithic and a distributed architecture, visually showing you what the stovepipe is all about. So here we have a well-formed architecture. This is not architecture by implication. These are well-defined components for an order, fulfillment, and entry system. However, what happens? We add additional behavior. So, consequently, the system evolves. And when we add that behavior, it's costly to think about architecture. So we start adding things like purchase orders, ebook downloads, audio streaming, inventory reporting, an AI chatbot that we're bolting on here. And notice what's happening. This is a monolithic system, but we're not paying attention to the architecture because it's expensive. Just add the video streaming in somewhere. And we start adding it in just haphazardly without thinking about components, and this system will come crashing down. The same thing happens with distributed architectures. This is a well-formed architecture where we have an HTTP client coming into one service and microservices, which we're going to be talking about next, that invokes another service to do something. Well, the same thing happens. we add additional functionality. And what do? We start adding different services. We add service C, but A now has to communicate with service C. But C needs information from service B, so it communicates with it. Then we add some additional behavior, system D. Now, system A needs to talk to D, but D needs to also talk to B. However, it also needs to talk to C to get some data. And then finally, it needs to talk back to A, the original service. We add some additional behavior now. And now E needs to talk to C, and C needs to talk to D, and so on and so forth. And you can see what happens. As we start to add additional behavior, as systems naturally evolve, what are we not doing? We're not paying attention to the architecture. And that is the stovepipe architecture anti-pattern. So how can we avoid this stovepipe architecture anti-pattern? And the answer is fairly simple. And it's focusing on what I call component-based thinking. In other words, if we see something with what I call an architect's eye, in other words, if I look at a system, I don't see classes, I see components. And as a matter of fact, in our book, The Fundamentals of Software Architecture, and we just released the second edition, chapter 8 covers this concept of component-based thinking, where in fact in this book, we actually talk about how to create and maintain a logical architecture, thereby avoiding the stovepipe architecture anti-pattern. Then in our second book, Software Architecture, The Hard Parts, we talk about component-based decomposition patterns. In other words, it's like, oh, well, we do have a stovepipe architecture. we had to rush. It seemed like a good idea at the time, but now we can't maintain this system. It just doesn't work. When we change one thing, something else breaks. There is hope. And that's what we did in chapter 5. We wrote about these decomposition patterns that allow you to do refactorings to the architecture, not just the code. And as a matter of fact, there's no refactoring of the behavior. It's refactoring the structure of the system to create definable components, subdomains, domains, to be able to not only migrate a monolithic system, but also repair an existing distributed or monolithic system. Let me show you a concrete example of this in action. So this will show you how both these anti-patterns kind of work. One of the architecture katas, in other words, it's a case study that we have in our book, Architecture, The Hard Parts, is what we call the SysOps squad. Now, the SysOps squad is a trouble ticket system. When you purchase electronics from our large electronics giant, you can also choose to purchase a support plan. And if you have problems with that electronic device, you can go onto our website, enter a trouble ticket, and our customer-facing experts, that's the SysOps squad, will come to your home or office and fix the problem. Let's actually model this particular system. Okay, so what we have is a customer, and what they do is they register with the site. In other words, I have a support plan, and I can maintain my profile. All of a sudden, my home entertainment system no longer works. So what do? So I go onto the website and create a ticket. The system looks for one of our SysOps squad experts in the field around your area and assigns that expert to your ticket. Once that expert's assigned, we notify the customer that your expert is on their way to the home or office. We upload the ticket to the expert's mobile device, and then they go to the home or office, fix the problem, complete the ticket. Once the ticket's complete, we send the customer a survey. How did we do? And hopefully, but usually not, we receive the completed survey. Okay, I got an idea. What do I mean component-based thinking? What do I mean think about a system and components? Let's create an architecture for this in like 3 minutes. So I'm a software architect. I see this flow. I'm looking at the problem and I say, I really see 3 domains. There's a ticketing domain, a customer domain, and finally a survey domain. Well, within ticketing, what do we need to do? Well, we need to create tickets. Okay, but I'm an architect. I don't know how that's going to be implemented and how many class files and in what language, but I know we need to do it. That's a component. And also, I need to queue up tickets. So that's a component as well. But wait, hold on. Wouldn't that just be a queue? Maybe. Maybe it's a stream to going to Kafka or something, or maybe it's just database polling. I don't know yet. That's the implementation piece. But assigning a ticket is almost like the traveling salesperson problem. So I need to assign a ticket, I need to notify the customer and route. Customers, oh, and then obviously we need to complete tickets as well. Customers can register with the site, maintain their profile, and we send and receive surveys using templates that we have. Ticket completion ends up kicking off the survey. And we have customers that interact with these components and domains and experts here. There we go. Create an architecture in 3 minutes. Okay. So that's all well and good, Mark, but how do I know I'm not in any of these anti-patterns? Oh, because we can actually see the architecture through the implementation of the system. You see, domains are represented through the highest level directory or namespace nodes that we have. For example, there's a ticketing directory where all the code sits below that. Here's the customer domain, which represents by that directory or namespace. And finally, survey. Subdomains are identified through lower level directory names. In other words, assignment right there. And finally, how do we know what the components are in our architecture? It is the leaf nodes of our directory or namespace. That's where the actual code sits to implement ticket functionality, for example, or behavior. Here's all the assignment directories that represent those components, assigning, routing, and customer notification. Here's customer registration, and finally, all the survey stuff. Okay, so that's how we associate an architecture with the implementation of the code. However, after production release, this is what that directory structure or namespace looks like. Now, this was generated partially by agentic AI and also by humans, but guess what? All behavioral tests pass. This system has every single test. As a matter of fact, let's another anti-pattern, which of course is 100% code coverage, but let's just say that we have 100% code coverage. Everything works, but do you see what we're focusing on, everyone? It's the behavior of that system. However, where is ticket assignment? Looks like we're a little bit frozen again here. Little glitch. Oh, there it is. Okay. Where's ticket assignment here? I mean, there's our architecture, and I think you'd have to admit the architecture is pretty clean. It's easy to understand. We've taken on some complexity and made it simple through an understandable architecture based on components. I don't know where ticket assignment is. What about customer registration? I mean, I see subscriber down there at the bottom, but I don't know where that code is. And by the way, I see this mobile connection. It's not even in my architecture, but it's a leaf node or a leaf directory. So that means it's a component that I don't even have. Here's send survey, but where's receive survey? You want to see something really interesting and scary? If we reverse engineer all of that code, the structure of the code, its dependencies, the components, and the domains, this is the resulting architecture. Now, this is a good exercise after this webinar to actually just reverse engineer your system. You know, it's interesting. It all works, by the way. The behavior is 100%, but we can't understand the system. As a matter of fact, we might even say that this is another anti-pattern called accidental complexity. All right, so what? We can agree these two architectures are nowhere close to being equal. Yeah, but you know what, Mark? The system works, okay? All the tests pass, the behavior, everybody's happy with the system. Really, let's talk about why this is a problem. Which of these two architectures would you consider to be more agile? Agile being the ability to respond quickly to change. In other words, maintainability, testability, deployability. Now, clearly the left-hand side. Which one of these do you think has better overall reliability? In other words, I make a change. Do I break anything else? Everything's interconnected. If one thing fails, it all fails. Yeah, definitely the left-hand architecture. Which one of these two architectures would be more adaptable to changes in our environment and technology and upgrades to versions of our frameworks or whatever languages we're using? Yeah, definitely the left-hand side. Which one of these two architectures would be easy to extend to add additional functionality? Definitely the left-hand side, which brings us back to the stovepipe architecture anti-pattern. And finally, if this system is a monolith and we want to break it apart into a distributed architecture, which one of these two systems would be easier to migrate? That's why architecture is significant. The behavior is one part of a system. Its capabilities is another. So, how to avoid this anti-pattern? Basically, anytime you're incorporating new functionality in a system, always ask these questions. Which component should include this new functionality? We focus our eyes as architects on components, the building blocks of the system, and say, which one's most appropriate? Or should I create a new component for this new functionality? And how does it interact with other components in the system? All right, so those are some anti-patterns, a couple out of the many. Well, as a matter of fact, we have 38 patterns, anti-patterns, and pitfalls in our book. Those are two of them. But I want to spend the rest of the time we have on talking about pitfalls. These are something that is never a good idea, even from the start. And as a matter of fact, let's talk about the first pitfall. Microservice all the things pitfall. This pitfall is basically assuming that all systems and all parts of those systems should be microservices. Oh yeah, we're implementing this system as microservices. Okay. What's the assumption? The entire system will be microservices. Yes, and this is a pitfall. There's no benefits to this whatsoever. If you think about microservices from a capabilities standpoint as an architecture, we see the reasons why it's so popular. I mean, look at agility, maintainability, testability, and deployability. 5 stars. As a matter of fact, scalability, 5 stars. Elasticity, 4 stars. Fault tolerance and evolvability, 5 stars. There's nothing better architecturally than this for these capabilities. However, what we have to pay attention to are what it's not good at. So, for example, we can immediately see here cost is 5 star or $5 signs. Yeah, that's going to be perhaps the most expensive architecture that you can ever implement. As a matter of fact, simplicity, only a single star. Now, 1 star is bad, 5 is good. Perhaps the most complex architecture in existence and not very responsive. And I put maybe here. And because things are improving with techniques and tools and frameworks we have to increase the problem of inter-service communication and latency that we typically see in microservices. All right, so what happens when we microservice all the things? Well, every function ends up becoming a microservice. That's the definition of microservices. Single purpose functions deployed as separate units of software. But what it means is we have to form bounded context with the data. And folks, modeling fine-grained data is really, really hard. So we take our entire system and we create it all as microservices. And let's say this is an order entry system, order entry and fulfillment system from a common retailer. Okay, here's all the superpowers for microservices. So let's take a look, because there's superpowers, but there's also kryptonite, cost, simplicity, and performance that are going to be bad. Well, let's take a look at our system. Here's the admin functionality. Maintaining name value pairs, doing all the administrative stuff in the system. There's 2 admins, by the way, that we have. We don't need any of these superpowers, yet we create that part of the system as microservices. So we get no benefits, but we incur all of the kryptonite. As a matter of fact, down here happens to be our automated warehouse replenishment functionality. Same thing. We don't need any of these superpowers that microservice is providing, but we end up with cost, simplicity, or complexity, and performance. Up here, we've got all the back-end order fulfillment functionality. Again, we don't need any of these superpowers, but we incur all of the cost. And over here, this happens to be our customer-facing sign-in, browsing, order placement functionality. Aha! That's where we need the superpowers, but we also incur the kryptonite. That's our trade-offs. So this is the problem with microservice all the things. We end up creating microservices when we're getting no benefit whatsoever. Now, a final pitfall that I want to meld inside this one, and I'm going to show you then how to avoid both of these pitfalls, is another pitfall called the grains of sand pitfall. The grains of sand pitfall is making all of your microservices too fine-grained. So it's related to microservice all the things. I coined this anti-pattern in 2016 after seeing this in the field constantly at different client sites. Picture a beach and all the sand on the beach. That's what your system looks like. Each of those grains of sand is a microservice. So taking both of these 2 things into account, what we do is say, whoa, micro is small, Mark. That means all your services should be small. But guess what happens when we make things too fine-grained? They all need to interconnect. Inter-service communication for functionality, for workflows, and mostly for data. And you can guess what happens when we do this. Yeah, the system comes crashing down. So how do we avoid these pitfalls? Let's close out this webinar by talking about how to avoid these things. It's a simple answer, folks. How do we avoid these 2 pitfalls? Horses. There you go. All right. So, Paul, we're all set. No, I'm kidding. It's like horses? Wait a minute. What are you talking about? When you move to microservices, either through a migration or through just creating it from greenfield, creating or migrating to microservices is exactly like a steeplechase. Now, a steeplechase is where you race horses really fast and jump over 8-foot-high barriers. Yeah. Well, if that's the case, which, by the way, it is true, how many of you have ever done a steeplechase before? And I imagine none of you are raising your hand. So I ask a follow-on question. How many of you at least have ridden a horse recently? I may get 1 or 2 hands raised. But if you've never ridden a horse or never done a steeplechase, this is what will happen to you. You'll fall off that horse and get hurt. And this is the pain that most teams and most companies are in the past and currently facing with microservices. So, how do we avoid these anti-patterns? Here's how we do it. If you've never done a steeplechase before and you've never done microservices before, doesn't it make sense to first learn how to ride a horse? Yeah, if we're doing a steeplechase, I don't want to get killed. I don't want to get hurt. Yeah, let's first learn how to ride a horse. And once we've mastered that, Then we learn how to ride a horse really, really fast and race those horses. And once we've mastered this, then and only then do we embark on this steeplechase. And I bet you're saying, Mark, what in the world are you talking about? You're talking about all these pitfalls within microservices. And now you're talking about horses? Let me show you how these connect. What does it mean to learn how to ride a horse? What it means to avoid both of these pitfalls is to move or create a service-based architecture first. A service-based architecture is where we have very coarse-grained services that represent a domain in the system. So instead of thousands or hundreds to thousands of services, we have maybe 2 to 12. So here's the point. There's our admin functionality, all of it in a single domain service. Here's our warehouse functionality. Here's all of that fulfillment functionality, and here's our customer behavior. And notice we're all sharing the same database, because that's the real hard part. So this is what is meant by learning how to ride a horse. We move here first. And here's the reason why, because now, when we now go to learning how to ride a horse fast, that part is knowing which portions to change and when. In other words, let's take a look at our microservice superpowers. Do we need these for admin functionality? The answer is no. How about warehousing? Nope. How about fulfillment? Nope. How about customer? No, well, no, hold on, wait a minute. Agility, scalability, elasticity, fault tolerance. Yeah, that's where we need it. Folks, that's what's meant by learning how to ride a horse fast. We move here first and then only break apart those particular services, those domain services that need to be broken apart. And this brings in that grains of sand anti-pattern or pitfall. So now we look at both of those and say, yeah, admin, warehousing, fulfillment, these are fine. Those don't need to be microservices, but customer does. That's where we need the superpowers. So let's close by recapping 4 main points. So in this journey of anti-patterns and pitfalls, we apply architecture when you need those capabilities, you've got some complexity, and have a low degree of ephemerality. Don't forget that's opposite. It's a little odd, but meaning a low degree of ephemerality is this system's going to stay around a while. But the key point is, it's not any one of these. It's thinking about all 3, because I demonstrated for you a system that had a high degree of ephemerality, and that was the ticketing system for the Taylor Swift concert, but needed an architecture. The second key point here, think about your systems as services as consisting of components and continuously govern those components. Third key point, not every portion of an application or system has to be microservices. We tend to think it does, and that's microservice all the things, but not all parts need those superpowers. So we get no benefit, but we incur all the cost and complexity. And finally, the last key point here, start out more coarse-grained with your services. And this is the grains of sand pitfall. And only move to fine-grained as you learn more about those particular services. And these 4 key points will help you avoid both of those anti-patterns and also both of those pitfalls. So there's a little journey of just 4 out of the 38 that we have in our book. But these I thought were really important to talk about in this webinar, because these are real, folks. These are out there. And our goal is to try to have companies and teams avoid these anti-patterns and pitfalls. So, oh, right. Well, Paul, we are at the, Bryce, we are at the conclusion of the webinar, but I'd be happy to take on any questions or have any sort of discussions related to this. So anyways, take it away, Bryce.
Well, the great presentation, Mark, and you've had horses in a presentation. I love horses, so any presentation with horses in my book is really awesome. My first question is, I'm Canadian, and I saw the Royal Museum, and I've seen it with friends, and this is very much like looking at the ugliest anti-pattern in the world. And my friends are
Mhm.
standing next to me, and they're going, "Wow, what a brilliant museum!" And I'm looking at them, and I need to tell them that the baby is ugly. How do you have that conversation with people to tell them that what they're doing is, they need to look at it in a different light? Like, can you share some of your tips on that so we don't get in trouble and maybe get people irate and marching on us and
Yeah.
stuff?
It's amazing. I've not known anyone, Bryce, that has thought that that is a beautiful building. As a matter of fact, it's not only architecture by implication that produces those kind of ugly buildings, but another anti-pattern that is called the witch's brew anti-pattern. Now, the witch's brew, if you think about a witch stirring a brew in a big pot, and it's got eye of newt and toe of frog and all these kind of things, it's basically an ad hoc collection of ideas and such that no one on the architecture team can agree on the architecture. So everybody just kind of does their own thing. And there's no cohesive vision of that architecture. And that's really what produces those kind of, well, ugly buildings and ugly architectures. Um, a lot of times, all I do, Bryce, is I show that image and then I show the architecture and say, this is kind of what your architecture looks like. And, a lot of times it's a great question because we do form hybrids. I mean, rarely do we create an event driven architecture. No, parts of it are event driven, parts of it may be service based, maybe a part of it is microservices event driven architecture. And so consequently, we do see these kind of hybrids, which is good, which is a great thing. But when the capabilities, and that's what I usually focus on, those architectural characteristics, start to be impacted by those particular kinds of architectures, that's the demonstration defeats discussion part about convincing teams to say we need a more cohesive architecture. You know,
Great answer. I wanted to talk a little bit about your breakdown when you started the architecture examples, and the example you used a domain breakdown on things, right? And
Mhm.
this is very different than in the, using, say, a class diagram. And I want to make that point really clear. So in the old days, or at some point, people found that reuse using class hierarchies wasn't that great of an idea, but component reuse practically turns out to be a very good idea. Why is that?
Hmm. It's interesting. I kind of showed that sysop squad architecture. I purposely made it sort of simple so that we can get through it in 3 minutes, but also just to really cement the ideas. And as a matter of fact, component reuse is something. Well, let's put it this way. Let me go backwards. I mean, reuse in general
Yeah.
is a normal and necessary part of software development. I mean, we can't get around that. We went through a phase, at least I say we, the industry is what I experienced. Let me rephrase that. In my experience,
Yeah.
we went through a phase where we started to embrace this principle called wet. We have dry principles, and this comes from the 90s in the Agile Manifesto. Don't repeat yourself. Then we went to wet, which is write everything twice, and that's what it stands for. I love these like acid versus base transactions because they're opposites, wet versus dry. But we started to embrace this idea in microservices where we want to avoid reuse. As a matter of fact, back in, I think it was 2017, maybe it was even earlier, microservices was termed a share nothing architecture style. Because it's what destroyed or was really hard with microservices. And so consequently, replication was the name of the game. In other words, wet, uh, avoid dry and stay wet. However, I think we learned a valuable lesson from that. Certain static things we can replicate. But we do need to share common functionality, infrastructure concerns about security, logging, metrics gathering, auditing, all these kind of things, date formatting routines. What we found happened was when we embraced wet, business functionality, behavior started to diverge. And we fixed a bug over here, but we forgot about fixing it here. And those two things will never equal. And it created very unreliable and brittle systems that were unpredictable, I guess I would say. So, based on that kind of wave, we started to then embrace shared components. And, in most distributed architectures, those are in the shape of either shared services or libraries, shared libraries, jars, DLLs, those sort of things.
Yep.
So, from a domain perspective, and now coming back to your question, typically I will create. I'll pick one word. Shared stuff. I'll be polite. And that will be the name of the directory under each domain, and maybe even its own infrastructure is what I usually name it as a domain. Infrastructure, I like that because it's part of the team topologies of maybe a platform team, which is responsible for logging, security, auditing, all of those kind of things, maybe a service mesh. Service discovery, all of those things are part of the infrastructure, and it happens to be shared. But we may have shared stuff within customer. And so I'll create a shared stuff component. And now what I've done is I've turned to explicit coupling as opposed to implicit coupling. Holding those files, let's say, in the root directory of customer. They're orphans. They have no home. There's no component association. And that's what we call implicit coupling. And that's what creates brittle systems. We start breaking stuff. However, making it explicit and making it a shared component with a very specific name that's common across all those domains and subdomains, now it turns it explicit. And I can actually now govern it to say how much shared logic do we have in this system.
So in other words, you're bringing out your cross-cutting concerns. You recognize that you can't isolate things, but you need to have stuff explicit that's shared. And that's a great point. And it brings me to my next question. You were talking about start coarse and go fine-grained. And I'm thinking, okay, I'm at a bank and I got something like a core, an old core banking system, and I want to modernize it. How do I actually find these common areas to bring them out that are shared? And is it just like any tips around that? Like as I evolve from a monolith really to a better structured monolith that actually has services in the right area? Because I think what I'm hearing you say is that some areas are probably going to remain part of that core banking system, right? And others get pulled out based on need, right? And we need to make things explicit. Is that by experimentation? Is there a bit of insight? Any thoughts on that, Mark?
Yeah, there is. As a matter of fact, if we had another hour, I would actually describe the entire decomposition pattern for you. But in chapter 5 of our hard parts book, Software Architecture, the Hard Parts, we talk about all these patterns. The third pattern is actually extract common code. And it is a kind of a process by which, as we're starting to reshape our architecture and identify components and resize those components, we start identifying what code is shared. And that's not as hard as you think it is, because the tools and IDEs really will tell us that. Tools like SonarGraph will tell us this information. It's like, well, what class files are shared? And we can start to identify where those are shared and start to extract that code into shared components. And the point of that is not to just make one large component that has all the 200 classes that are shared across this domain, but rather starting to scope and think about the groupings of that shared code, so that we don't get too fine-grained, but we're also not too coarse-grained in identifying that shared code. But it is one of the patterns to actually start looking for that code and saying it needs a home. And what domains are actually sharing that? And is that appropriate? And maybe that's where we make that distinction between Do we use dry principles or do we use wet principles? And again, that depends on the static nature of that particular code.
Paul, welcome back on board. And
Hey, Paul.
before I let Paul comment, there are some questions that have come up on the side. And one of the questions that really strikes me as interesting is, okay, how could we as architects constrain agentic generated code to ensure the design and characteristics are followed? And I would imagine what they're saying is, how do we make sure in an agentic world we're following the advice that you were talking about today? Any thoughts on that one, Mark?
Oh my gosh, yes, that's exactly what our upcoming book, Architecture as Code, is all about. And as a matter of fact, there are 8 intersections of architecture that we can actually teach agents about regarding our architecture. About two and a half years ago, Neil Ford and I created a description language, ADL. It's called Architecture Definition Language. And this is a kind of a pseudocode way of being able to describe our architecture. It was never 2.5 years ago our intention to actually have agents learn about this. The intent originally of that principle, the ADL, was to take a description that a human can read and generate ARC unit code or NetArc test or PyTest ARC or GoTest kind of code to govern the structure of the system. And turns out this has evolved significantly. So the book is basically about how to teach agents about your architecture, not only the structure, but the infrastructure, the team topologies, the enterprise, the business environment, engineering principles that we may want to adhere to, certainly our architectural characteristics, our data topologies, you name it. And it's not only to govern the architecture, like I showed you those 2 different architectures after production release, but it's also that when we use, not if, but when we use agents to generate code, we can have those agents say, given this ADL description, this is the logical architecture and also the physical architecture in terms of services that I want you to create. Because agents are great at behavior, but they're really horrible at architecture. Now, Paul and I were talking earlier. As a matter of fact, Paul has a tremendous amount of experience with Calm. So Calm is an effort that's going on by the Finos group. That's the open source finance group that based at finos.org. So if you want to look at that, it's calm, CALM.finos.org. It's called a Common Architecture Language Model. Now, the difference is Calm is an actual specification. In other words, it has a formal spec to it, and it's mostly used for describing the physical aspects of an architecture. So that's really where they differ. ADL is, and we stumbled upon this accidentally, and that's how I think most great inventions happen. You stumble upon these things accidentally, like plastic. When the cat knocked over the little beaker in the lab, guess what? We have plastic by accident. But here's the key point. When we talk about agentic generation or even analysis, agents use an LLM, large language model. And that second letter is language. Agents understand ADL extremely well because it's not a formal spec. It's written in pseudocode. And so consequently, humans can understand it as well as agents. So that's really where the difference lies in terms of an agent having to understand a formal specification versus just a structure that then it can use to govern and actually create a system based on an architecture that we specify.
I should say too, and I think so, many of the ISO belief systems are that the profession needs to begin to govern itself. So the Bitterbuck includes an area for what we call the structured concept approach, structured canvas approach, which allows you to specify tools like business models, right, Mark, and things like that, where you're saying, oh, well, here's a customer journey looks like in our area or whatever. And what we found and I don't know how you're doing your ADL, and I really want to hear more about this because it sounds like a beautiful combo, is what we ended up finding is that what we were really defining is a kind of knowledge graph or an ontology, right? And what is a decision record, I think, is a very interesting question, because there are really, the Bitterbox says there's 3 types that we've captured from members of decision records. I don't know how many different types you've seen, but there's not that many. And they have fields and things like that. And it really helps the agent in our coding environments to understand when we say, oh, what would the decision look like for that? To go out and be able to say, this is what a decision record is. Not what it's learned in its training set, but one definitive source where it can go, oh yeah, here's where a decision record, and that's what they look like. So it can be one of 3 types, and here's how they're written, and here's what goes in each section. Significantly faster time to complete on any of those things. So I don't know where ADL, and I want to dive into your architecture description language, because for us, we were involved in MOF early on, and some of those kinds of things. I was with the, and it was a little messy stuff, but definitely, you want to talk about standards by committee? That's what that was. Yeah. So no, don't want to go there. But we found this wonderful balance between flexible definition of things that naturally link to each other. As you know, let's say a context view naturally connects to decision records as well as sequence diagrams, right? But it also generates kind of other things, principles come out of it. And we've got so in the Bitterbuck right now, we've got a thing called Coddle, which expands over Calm. And it basically is the agentic meta model, the data model for the whole canvas approach, the whole rough here. If I want to do a performance view, what does that include? Yeah. So I think it'd be really interesting to combine that with a pseudo programming code kind of environment where you could specify rules of that. I don't know, maybe they combine well, maybe they don't, but I really believe that we need architects to agree, not just a leader, but a place where we can go argue what our definitions are and have those reflected in the agentic environment, right?
Yeah.
You guys think of that?
Yeah, absolutely agree. The struggle that we being Neil Ford and I had with ADL, and we've kind of overcome that a little bit, was describing the detailed infrastructure, the details of the deployment and the implementation. This is what Calm does, and it does it extremely well. And as a matter of fact, it can be used in automation through a CI/CD pipeline to be able to actually deploy a system with all those endpoints defined and names defined and the physical architecture of that. And that was one of the deficiencies that we struggled with ADL. And the reason I bring this up, Paul, is because I'm not convinced that there is, or there may not ever be, a single specification that can describe everything from a logical architecture all the way down to the actual physical deployment. And that includes even the team structures, the infrastructure, the engineering practices. This Calm does not do well, and ADL does. My point being that unlike ADRs, I think it's combining different tools to satisfy different architectural concerns. And so I think
language is the breaking point. You brought up language, and I kind of want to challenge that, because if I speak French, I don't know, do you speak French?
Oui.
Oh shit! If I start speaking Japanese, do you speak Japanese? Okay. Okay. So the point is if our language is not the same language And this is what I find most in the teams that we go analyze. And we've done 200 large organizational architecture practices. And it's not that they can't do a high availability design. It's that they all do a different thing and call it a high availability design.
Sure.
And even more basic than that. What do I do for a business process, right? What's the thing I fill out? What's a requirement? What's a user story? It's literally basic language tasks.
Sure.
And I'm curious, so where do you see that stuff for us? Because honestly, that's our biggest, don't you see that as being like one of our biggest difficulties in growth as a group, like maturing as a body?
I absolutely do. Yes. And we tend to waste so much time with another anti-pattern, which is reinventing the wheel anti-pattern.
Exactly.
And here's where I see your point as it would be really nice to say, we need a requirements document. Okay, most companies say, yeah, this is our requirements document. This is how we've always done it and all this kind of thing. But it would be really nice to have a central place to say, well, where's a good starting point? ADRs is such a great example, Paul, because there's 5 basic fields in an ADR, but I use 8 because I add, how am I going to govern this? There's a governance section that I have in my ADRs. There's a metadata. I mean, who approved this ADR? And did it go to an architecture review board? And when was that? I want to know this information. And who modified it last? Now, if it's stored in Git, we can get some of this metadata, but Git's not going to tell me who approved it and when. So my point is, though, that there's a base that we can work off of. And I really agree with you that, and maybe this is the place that this happens to say, I want a basic description language. I want a basic model of how do I do a logical architecture? How do I describe my physical environment? And then you modify it to your needs. And I love that idea. We're not there. We're not even close to being there. It's interesting when we talk about this of some of the standards, like Open Group's Archimate type of standard, that they made a lot of efforts to try to standardize the way we describe and diagram our architecture, specifically diagramming it. And it's a standard that's adopted in a lot of companies that I work with, but I wouldn't call it a standard because it doesn't work in all situations. It kind of gets in the way.
I love this
systems.
I love this conversation. Grady Booch was one of the first person I called when I decided to start ISA. Yeah. So how did Grady get famous? Oh, he invented UML.
There we go.
Wait, okay. What about Simon Brown?
Oh, yeah, with C4.
Simon Brown and C4.
Oh.
Which is interesting because now C4 is C4 plus D plus a couple of other things that you don't fit in the name because it starts with a C. But I saw Simon
was a great place to start. Yeah.
Yeah. And now here's the thing. Those are just model types, which convert to Calm beautifully, right? They're wonderful things. They go into Calm. But a lot of our stuff, like you said, are process artifacts. Yeah, governance reviews. And when we're doing our sprint planning and what's an architecturally significant requirement versus just a standard user story or Epic or something, right?
Yeah.
Quality attributes. So I'm curious about your thoughts on this because we just had a wonderful speaker on talking about quality attributes. And SARM and the analysis methods for hardcore like ATAM, on quality attributes. There are no canonical designs at all for many of those spaces, right?
Correct.
Once you get past a performance, once you get past a sequence diagram, how do you model performance, right? Or secure attack. I was trying to look up what do you think we need to do as a group? Right? Where would you take us if you had the magic key as a group to do that stuff? Bryce, you've been quiet, by the way.
I do have a question about ontology, but I'll save it for this answer. So my question mark is, when you act as you had mentioned, like agents or using large language models, a lot of times you can get hallucinations, and some people have found that when you have an ontology backing a more procedural description of something, you get less hallucinations.
Mhm.
And I wanted to get your thoughts on the importance of including an ontology with the procedural description to, like, get this thing to reason about,
Mhm.
architectural language and things like that.
Yeah. One of the things we actually found and were able to actually demonstrate and actually quantify, not only just qualify, but quantify, was the kind of similar to what you're talking about here with how do you describe these kind of things to agents? And it requires a lot of prose, and all that prose requires a lot of tokens. So one of the things we found again by accident with ADL was being able to describe these kind of aspects of our architecture in the most concise way possible that an agent can still understand. And also a human can understand, because we write so much prose in our skills or our markdowns for, let's say, Claude, that it's like reading a requirements document, and we got to maintain that requirements document. And so we saw this as a problem. We ran through a lot of experimentations of taking a problem statement. In fact, it was SysOps Squad, and basically tried to describe not only the behavior problem, but the architecture through prose. And then still describe the behavior, but then the architecture through ADL. And it was a very significant decrease in token usage, as well as performance and speed of code generation. So, my point is, I still see this as a struggle and a current issue that we have when we start talking about agentic generation.
If you were getting into then the legal, so we're, as you may be aware, we're actually at ISA, we're actually now getting to the point where we're starting to talk to governments. Yeah, and governments, especially in Europe, are starting to get in the game a little bit. Like, oh no, we don't want your, and of course in the US we have the big, we don't want your data center stuff, right? So the populace is also getting into the game, which means the politicians are getting into the game. Okay, what happens when we need a rigor? It's not a retail system where if you get it wrong and, okay, we could lose some credit cards, and that's very serious. But it isn't the power grid goes down in America, in America goes,
Right.
So what do you think are the main steps to getting, especially in agentic, which I like primarily because it forces us to stop being quite so much artists and start being scientists? Like, yeah. What do you think the big three things are then in writing architectures, creating architectures that are the holy grail of that?
Yeah, well, one of the things, and this comes back to Bryce's question as well about the hallucinations, is, and this I see, I see this at current client sites, where we take code that's written by an agent as this is gospel, this works. And one of the answers to your question is the fact that we have to verify as humans all of the code that's generated. To Bryce's point, oh, let me generate a test for that. Yes, that test passes. And we look at the test and it's not testing anything. And so the task is get a test to pass. And so consequently, that agent will make sure that test passes, but it's not complete. And so this as well as just if it's behavioral code, or whether it's fitness functions that are used to govern the application or the system. We have in our book, Architecture as Code, we really define two types of code that's generated from AI. It's empirical or interpretive or interpolated. So interpolated code is if I ask Claude to say, hey, can you find out what are my current assets under management? Oh, let me go calculate that for you. Okay, that's interpolated. and I can't trust that answer. It still can't. It's likely that's the answer, but I have to verify. Versus having an agent say, generate for me some code that I can calculate the assets under management.
Yeah,
exactly. I get that code. Now I, as a human, verify that code. I add it as an MCP tool or just as a simple function. And now I can have an agent execute that. That's empirical. And so consequently, this is one of the ways of avoiding the hallucination piece, or just making the assumption that, yeah, the code works. Look, Claude even tested it. It's like, yeah, did you look at the test? Well, no, it passed. Assert true, semicolon. It passed. You told me to make a test pass. It passed.
You know, what about intent there, though, Mark? I mean, this is what I think the question, and we should probably, we didn't schedule this for an hour and a half, but I'm more than happy to keep going. Carol was on for a little while, and he runs his a proper length because he knows that architects are going to just go crazy. Yeah. I was not. So intent. So everybody talks about requirements. And we've fundamentally gathered that the requirement to deployment was our traditional traceability. That was all we were ever really responsible for. If it met requirements or the test passed, you know, and the requirements were all like, it will have a blue button and the blue button will make it, you know, add to order. Yeah. And that was it, right? It didn't talk about whether or not people ordered online and whether they ordered the right, you know, the maximum things they could order. There was no real intent in the conversation of architecture. Now, we've been arguing that architects, right, the developers, that's fine. That's perfect. Great little circle. I don't want to know anything about intent. I just tell me the requirements and I'll implement the best structure possible. And that's great for developers. But architects add something different, or I believe, and I've heard from a lot of others, and that is the broader intent, the mission, the goal, the objective, right? Buy more stuff online is a better thing intent-wise than have a blue button that will add things to carts, right?
Yep.
Where do you sit on intent? Because all I hear in anybody talking is structure and requirements, architectural decisions that implement requirements. And yet the quality of those requirements is often dismal, especially these days.
Yeah. It's interesting. I wish we had another hour on this, but I unfortunately do have to drop off. But where do I sit in terms of intent? You know, I see it more aligned with the capabilities of an architecture. Neil Ford and I started to switch over between discussing architectural characteristics, which we've defined in all of our books, to starting to talk about those characteristics. And when I say an architecture characteristic, it's what we term quality attributes, non-functional requirements, et cetera. But we've started to turn that over to the word capabilities. Capabilities include those architecture characteristics. But where I sit on intent is I think that the capabilities of that system is where it includes that intent as well. So in other words, you've got your core structure, you've got your architectural characteristics, and you've got the intent that you're speaking about now. I see all three of those, and plus other factors, about the capabilities of the system, not the behavioral capabilities, but the architectural capabilities of the system.
Okay, would you volunteer to join a call with a set of business architects and integration architects and infrastructure architects to talk about the word capability, just because? Oh my God!
Paul,
no, not another one.
I was teaching a class.
Definition.
I was teaching a class recently on the architecture as code, and continued to say capabilities. Finally, after about 10 minutes, one of the architects came up to me and said, "Would you please stop saying that word, because it's confusing everybody? Because here at this company, we use the word capabilities to mean business capabilities, and you're confusing everybody." I said, "Oh, okay." We'll use characteristics then. So yes, to your point, oh my word, yes.
Yeah, so we have a lot of business architect members, and just so you know, the Bitterbox does identify both individual technical capabilities in the technical landscape article, which I think is a very valuable addition, something that TOGAF talks to a little bit, but also there's a number of other, standards communities that have connected that, because we also have the horrible word services and you know, so we do agree though that fundamentally capabilities, both business and technical capabilities, contribute to the value measures and intent. It's the changed behavior that we want to see, the OKRs, the business process modifications, those kinds of things that seem to constitute a fundamentally different thing. You are actually correct though, in that we have gone way over, and I've kept you so long, and you've been such an amazing guest. And I really hope that we don't wait 2 years. Maybe we could just have a twice a year scheduled moment or whatnot, just to catch everybody up with whatever the amazing things you're working on.
Yeah, I would love that. Yes.
I will buy the next book if you will sign it. I will buy it anyway, even if you don't, but still.
Sounds like a great plan. Yes.
So anyway, thank you so much. I mean, brilliant stuff with the latest book, the ADL, the just helping so many technologists understand how to build better systems. I could keep going forever, but I really thank you for this time. And Bryce, my co-host, who has bravely been silent, letting me kind of bather on with you a little bit, banter back and forth. And thank everybody else for coming. Next 2 weeks from now, it's every 2 weeks. It's not every 2 weeks, twice a month. Damn the calendar. We have a wonderful presenter join us, the same live webinar. This recording will be available for ISA members, Explorer and above, in about an hour. It comes online very quickly. So if you missed something, you can always refer back to it. Mark, anything, any place anybody can see you, talks you're doing, conferences, training classes?
Absolutely. On my website, Developer to Architect, it's TO, developer2architect.com. Tons of resources. I do monthly lessons. You can see my upcoming events, where I'm at. So yeah, that's the place to go to get free resources and also just find out a lot about architecture. So, and I do want to put a plug in for Michael Carducci. He's a good friend of mine and an absolute wonderful speaker.
He's got a new book too.
Yeah,
and everybody here but me has a new book. Bryce has a new book as well, right? Which we talked about on one of these calls. So Michael's got his new book. I actually don't have it yet. I've got to go. I was trying to get a physical copy, but I was changing addresses. So I've got 2 weeks to read it. Wish me luck. It's supposed to be like this.
You won't be disappointed with his talk. He's a great.
I'm never disappointed with Michael. He's amazing.
Topics, so yeah.
And thank you all of our attendees. You keep tuning in. We'll keep bringing you more talks.
All right. Well, thank you so much, Paul, for having me on again, and we'll see you soon. All right.
Thanks.